I'm Cliff Tryons, Director of General Public Outreach for the National Groundwater Association. It is my privilege to introduce our presenter, Michael J. Schnieders, a professional geologist and professional hydrologist with a specialty in groundwater. He is also president of Water Systems Engineering, Inc. in Ottawa, Kansas. Mike has worked extensively on water quality and water chemistry issues and on designing more effective water well systems. He has delivered numerous presentations to scientists and engineers, water well system professionals, and household water well owners. Mike is also the 2017 William A. McEllhiney Distinguished Lecturer in Water Well Technology. During the presentation, feel free to type questions in the question box. At the conclusion of Mike's presentation, he will answer your questions. So without further delay, I'll turn it over to you, Mike.
Thank you, Cliff. Good afternoon and welcome to our presentation. Today's webinar is entitled Water Well Disinfection. Our program was designed to address the subject of well disinfection, some of the reasons behind this practice, and the challenges encountered. The program was designed for private home well systems, but many of the same concerns hold true for larger municipal well systems. As a reminder, today's presentation is part of a cooperative effort by the National Groundwater Association and the United States Environmental Protection Agency. The time you invest in this presentation could protect your drinking water quality and your health. Before we get underway, let's take a quick audience poll. You can click your answer on the poll section in the webinar control panel. What choice best fits your needs and interests in attending today's webinar? Are you here to learn more about disinfecting your well? Would you like to learn more to help others learn about proper well disinfection, or do you have another reason? We'll visit these answers shortly. Our outline for today's webinar was designed to address the basic questions that surround proper well disinfection, including whose responsibility is it, what are the vulnerabilities and why should we be concerned, how do you respond to a problem, and where can you look for help. I will also offer some additional resources towards the end and, as time allows, be available to answer your questions. Let's take a quick look at our results. Cliff, can you share those with me?
Yes, very interesting. Almost evenly divided. 52% wanted to learn how to disinfect their wells, and 48% wanted to learn how to help others to do proper well disinfection.
Excellent, thank you. So who's responsible? Unlike public water supplies that are regularly tested to ensure the water is safe to drink, individuals or families who own or utilize a private water well are responsible for the testing and maintenance of their water supply. What constitutes a private water well, and what are some of the common characteristics? A private well is one owned and operated by a private individual or group of individuals. Private wells typically serve 1 to 3 homes, with larger groups generally classified as a water system depending on your state's guidelines. Private wells are typically shallow, 200 foot or less, and constructed with common materials such as PVC, plastic, or steel casing. Generally, private wells are completed in close proximity to a home, with the connections running underground to limit the effects of freezing and weather changes. What are the vulnerabilities and concerns surrounding well systems? A properly constructed and maintained water well system is designed to keep harmful microorganisms and surface influences out of the well and the supporting water supply. Water well contractors are licensed and approved of by the state in which they work. Each state has a minimum set of standards for well construction that is generally established with an understanding of the geology and the aquifer systems present within the state's borders. These standards are designed to limit surface influences on the well and supporting aquifer systems. Harmful microorganisms include pathogenic or opportunistic pathogenic bacteria, protozoa and larger multicellular organisms such as amoebas or parameciums, as well as active and inactive viruses. One of the main goals of proper construction is to limit the influence of these harmful microorganisms on the well and aquifer system. The influence of harmful bacteria, larger microorganisms, or viruses can lead to a compromise of the well's water quality. Compromised water quality may lead to illness or even fatality. Certain parts of the population are particularly vulnerable to these impacts, including infants, young children, the elderly, or those with a compromised immune system. While different influences pose different threats, general symptoms of pathogenic bacteria influence can include diarrhea, cramping, nausea, or long-term headaches. When evaluating a water sample for a bacteria presence, there are two recommended means of evaluation. This includes a general population level and the presence of offending organisms such as coliforms. Two common tests used to evaluate a bacterial population are the heterotropic plate count, which depending on the method chosen will give you a count of viable organisms between 0 and 1,500 colony forming units. The second is the ATP test, also known as the adenosine triphosphate test. This comes to us from the health industry and gives us a population reading in cells per milliliter. As a point of reference, plate counts between 0 and 150 colony forming units or ATP levels between 1,000 and 30,000 cells per milliliter are considered normal background levels of bacteria present in the aquifer system. The most common test used as an indicator of potential contamination is the total coliform test. The total coliform presence is a very sensitive test that is reported as present or absent within the water sample. Similar to that is the fecal coliform test, which reports the presence or absence of E. coli-related organisms. When a water test indicates the presence of nuisance microorganisms, take the well offline and make arrangements to have the well system inspected by a professional. As part of the inspection, the well, operating components, and the area around the well should be evaluated. A water well system inspection can help ensure that the well system is operating properly. It can help prolong the system's useful life and help discover water quality health risks due to system maintenance problems or contamination sources. A well inspection should include a visual and physical inspection of the well head, exposed casing, and any other well system components directly attached to the well. Such an inspection can identify any breach in the well system or degradation of the well structure that has occurred over time, as well as help to identify a potential contamination source. Once the underlying reason for the problematic bacteria's presence in the well system is identified, corrective actions can be taken. Corrective actions can include repair of the well seal, physical repair of the well structure, installation of barriers at the well surface, or cleaning of the well from general buildup that has occurred over time. Once the necessary corrective actions are completed, the well can be disinfected. In addition to a failed test triggering a disinfection event, there are other times when a well should be disinfected. These times include after initial construction, before the well is turned on and used for consumption. The goal at this time is for a water source that is free of harmful bacteria. Also, when an existing well has been serviced. When we open the well, we can expose it to outside influences and potentially harmful bacteria. Another time is if there is a visible defect or damage to the well system. Damage or deterioration may provide a point of entry or a conduit for troublesome microorganisms or surface influences to reach the well and aquifer. If the well has become flooded or is otherwise breached, these events often introduce a variety of potentially harmful influences on the well. Excuse me there. If the well has been offline for an extended time period. During the recent recession, many rural homes were left vacant due to foreclosures and a general decline in the housing market. During this time period, the industry saw an increase in the number of water complaints when the home was reoccupied and the wells were reactivated. The complaints spanned from dirty or discolored water to the presence of a musty or rotten egg odor at the wellhead and taps within the home. Typically, these problems are a result of the well sitting idle and stagnation occurring. Operating the well and thoroughly flushing the system will usually improve conditions. Regardless of the symptoms improving, if a well has sat idle or has been offline for an extended time period, it is strongly advised that the system be thoroughly flushed, the well sampled, and disinfection of the well and water system be conducted. Larger wells, older hand-dug wells, and some specialty wells can present a unique set of challenges with regards to inspection and maintenance, and typically require specialized, more involved disinfection efforts. Well disinfection is one of the most common forms of well maintenance conducted, yet remains one of the most misunderstood. There are several key factors to conducting a successful disinfection treatment. First, we want to identify the problem or problems that are impacting the well and causing the issue. Second, we wish to correct the problem through modification of the well or improvements made at the surface. Third, pump the well to remove any stagnant conditions or low flow areas that may have developed. 4, if the well has not been cleaned recently or shows signs of mineral incrustation, conduct a thorough cleaning all the way to the bottom of the well. 5, disinfect the well correctly using the right chemicals and methodology. And 6, keep the well active, limiting stagnation or excessive periods offline. Even under normal circumstances, proper disinfection of a water well can be difficult for the untrained. There are many hazards involved in the application of chemicals, and opportunities exist to damage the well and potentially harm the water supply. On the safe side, we recommend utilization of a trained water well professional. Successful disinfection is not easy. Key steps in this process include understanding the chemistry and using the correct dosage, properly targeting the entire well system with an adequate treatment volume, adjusting the pH if you live in a hard water or alkaline water area, and allowing sufficient contact time. Studies have shown that use of a shock treatment of high chlorine concentration is generally inadequate. Research has found that chlorine concentrations between 50 and 500 parts per million are most effective. Generally, chlorination treatment of 200 parts per million in a pH range of 6.5 to 7.0 is advised. Successful disinfection is more than just pouring chlorine down the hole. Although familiar to us as household bleach, chlorine and chlorine compounds are very powerful oxidizers. Inappropriate use can lead to adverse chemical reactions with the various components of a well and water system, potentially react with other chemicals nearby, cause harm to your skin and respiratory tract, and potentially release dangerous and sometimes fatal chlorine gas. There exists a wide variety of chemicals and compounds for disinfection of water systems. Many of these products were not designed for water well use. The National Groundwater Association recommends disinfection products certified specifically for use in potable wells by the National Sanitation Foundation. Known as Nsf International, this organization is an independent product testing group. Many sources online and do-it-yourself types will recommend the use of household bleach for well disinfection. It is our belief that this is unwise. Household bleach is designed for use in washing machines, not water wells. Household bleach is buffered to an alkaline pH for safety, significantly reducing the disinfection capabilities by up to 300%. Household bleach often includes perfumes and stain fighters, which help in laundry, but further limit disinfection and may cause harmful reactions within the well. And lastly, household bleach, often sold at a 5 to 6% strength, degrades very rapidly, losing approximately 1% of strength each month. And that loss begins when produced, not when purchased at the store. On a similar note, as I mentioned in a few slides earlier, many do-it-yourself sites will recommend shocking your well as a means of effective disinfection. Shock chlorination typically indicates a chlorine treatment of 1,000 parts per million or greater in an effort to overwhelm or shock the bacteria within a system. Laboratory studies have shown that higher concentrations of chlorine have a higher rate of failure. The overtreatment results in the oxidation of available biofilm, the community in which bacteria protect themselves, creating a short-lived tightening that is often followed by a bloom with a significant increase in the bacterial population. The study found that concentrations in excess of 500 parts per million failed approximately 50% of the time. Effective disinfection is so much more than just pouring a chemical on the top of the well. For the most effective treatment, it is best to administer the solution over the entire well, which may require the use of a tremie pipe or piping to add the solution to the bottom of the well and to evenly disperse it over the entire water column, as in the picture on the left. To adequately address all the components of the well system, it is advised that you prepare a treatment solution equivalent to at least 2 well volumes. This is designed to completely treat the well column, the gravel pack, and reach out to the near well aquifer interface, as in the image on the right. Depending on the well construction and design, this may be upwards of 4 times the standing well volume. So let's take a minute for another quick audience question. You can use the chat feature in the control panel on the right to answer. Who here in attendance has attempted or assisted in disinfecting a private well and was unsuccessful? Names will be protected. We're just looking at numbers. Common problems that are encountered when well owners attempt to disinfect their wells, and this holds true for private wells as well as larger well systems, include over-chlorination and damage to well equipment, potential harm to themselves, poor distribution of the disinfection solution, damage to the well components or water system components due to the corrosivity of the oxidizing chemical, inadequate contact time between disinfectant and microorganisms, and a failure to address disinfection inhibiting factors within the well, such as the background pH or alkalinity. Each of these points gives us an inability, each of these points comes down to an inability to understand that disinfection is a more involved procedure. When treating a well, the job isn't complete with disinfection. It is strongly advised that you follow up any treatment efforts with testing to confirm that the well is free of the offending organisms. At a minimum, we recommend testing for total coliform occurrence. However, you should also test for any specific bacteria or microbial problem that is of concern to your well or to your area. If the well is properly disinfected, but follow-up testing shows the problem has returned, this could indicate that a breach or structural damage exists within the well system. A concentrated contamination source, such as a failing septic system or influence from nearby or adjacent animal pens. Or that the well is dirty and needs to be cleaned so that a disinfection solution can be more effective. As a precaution, wells experiencing a problem or failure requiring disinfection should be tested periodically after the well has been restored. We recommend an anniversary test be conducted on the anniversary of the failure or disinfection event as a means of proactive maintenance. This is especially true for wells that are not in continual use or only see limited seasonal use. We recommend that you utilize a qualified water well professional to inspect your well, conduct any indicated maintenance, identify problematic contamination sources and help to eliminate those problems, and disinfect your well system when needed. For help with questions, concerns, or locating a certified well contractor, you can visit wellowner.org, a service of the National Groundwater Association. Wellowner.org is a clearinghouse and excellent resources for well information. Some additional National Groundwater Association resources for small systems include Best Suggested Practices number 2 and number 15. Number 2 deals with reducing problematic concentrations of microorganisms, and number 15, residential well disinfection following a flood event. You can also reference these recent Water Well Journal articles, Well Disinfection, which appeared in the August 2015 issue, and Tracking Well Health, appeared in the January 2016 issue. For additional information on well water testing or to locate a testing lab, you can visit wellowner.org or contact your local sanitarian or county health department. Some additional information and helpful resources available on wellowner.org include the Private Well Owner Hotline, tip sheets for well owners, and a variety of lessons concerning ongoing maintenance and operation of your well system. And now I'll open it up to questions and answers concerning well disinfection.
Yes, I'd encourage everybody out there, if they have any kind of a question, to go ahead and write that in that question box. You know what they say, the only dumb question is the one never asked. So this is your chance to ask anything you've wondered about before regarding well disinfection. I do have a few questions. One is, I've seen instructions on how to disinfect water wells using household bleach. I know people have been doing that for years. Why the disagreement?
Well, for the specific reasons I listed, in the past 10 years, most of the commercially available or readily available at the grocery store forms of bleach are not true sodium hypochlorite. They have enhancers, including surfactants and perfumes, that are introducing additional chemistry into the mix. And furthermore, they're buffered to a very alkaline pH, upwards of a pH of 10, whereas 15 years ago, it was typically found at a pH of 8. That significantly reduces the disinfection capabilities of sodium hypochlorite solutions. Additionally, with with a change of shelving and stocking practices, generally the percentage of sodium hypochlorite that reaches the homeowner when they purchase that jug of bleach off the shelf is down to a 2 and possibly 3% strength solution. So it's already been reduced by half before you compound it with those additional chemicals and buffering of the pH.
Okay. Thank you, Mike, on that. Have another question. In your experience, what is the most common reason for bacteria getting into a well?
Well, that's a great question. And despite what the Internet and Wikipedia tell us, bacteria really have a universal presence. They exist in the bottom of the ocean and the top of Mount Everest. It's the types of bacteria and the quantity of bacteria that cause problems. There's not an aquifer that we found in our testing that was bacteria-free, but we have a wide variety in populations. And when we place a well into the earth, we're basically preparing a nice gathering spot for those bacteria. Now, through day-to-day and regular operation, you kind of have a steady state where we don't have problems occurring. But when they set idle, you can have a concentration effect occur, both with the water chemistry, such as with calcium hardness, as well as the biology. As these populations increase, and if they're not properly flushed out, they can start to reach problematic levels. Now, in addition to that, and just natural fouling and dirty conditions that develop, I'd say the most common breach is the well not being properly maintained. The well casing sticking out of the ground, unprotected, getting nicked by the mower, becoming inundated with floodwaters, or backfilled over on accident, and that causing a structural conduit for surface conditions. Maybe it's just soil or grass cuttings, but typically there are bacteria that are not native to an aquifer system within those items that then introduce a whole new type of species downhole.
Okay, thank you. We have a question. How do we check for parts per million? Is it a test you can purchase? So I guess they're talking there about the concentration of the disinfectant.
Yes, there are many methods available. You could, well, actually, I would not recommend you Google strip test, but there are a variety of very quick methods available. If you look on Amazon.com or go to the website for ITS, industrial test strips, there are some field methods that will help you look at the total amount of chlorine present, and you can get a high and a low range, so you can get a smaller value, a 1 to 50 range, or a 1 to 500, and it's in 10 or 25 part per million increments. And that would be the best method.
Okay, we have a question. It may be a little out of context, but you can probably remember which slide the viewer is referring to. Could you clarify how limited is limited use?
Unfortunately, the abandoned house picture didn't show up today, but typically if a well system is only being operated 1 day out of a month, it is going to start to experience biological congestion. Not uncommon for some wells, especially emergency backup wells, to sit 6 to 8 months out of the year without any operation at all. Typically, I'd like to see, I should say ideally, I'd like to see a well operated once a week for sufficient time to purge multiple well volumes from it. And the idea there is just to flush out any stagnation that's occurring chemically or biologically. If the well sits idle for a month at a time, then I would certainly plan to flush it multiple well volumes before I put it into use. And if it were to sit idle for 6 months or greater, I would consider a maintenance disinfection effort before I utilized it for a drinking water source.
Okay, thank you. We have a question. How do we know if we have a reputable well company? So I guess they're trying to get some pointers on how to figure that out.
Well, I would start with wellowner.org and look for well companies operating in my area. And then I would reach out to my local county sanitarian or health department, because they're typically the ones that hear the nightmare stories. This contractor did horrible, or the good stories. This person was great. They came out on the Thanksgiving Day weekend in the freezing cold. And I would balance that list with, with some personal references. And then certainly go online. There are a variety, for example, when you Google businesses, you can get some response and some feedback there of pros and cons of different contractors. You could also look for National Groundwater Certification, either displayed on their website or on the side of their truck or any brochures, and that would at least tell you that that person has taken some additional classes in a variety of specialties concerning the wells and passed the exams specific to those areas.
Thanks. I would add to that, since I spend a lot of time talking to well owners on this sort of thing, that basically, Mike, what you pointed out is this idea of doing a little homework in a variety of different ways to get a sense of how customer satisfaction and things of that sort, to be able to have some basis to distinguish between different potential businesses. So, okay, I have another question. This participant says, I have a weekend house at the Lake of the Ozarks. I had well problems. Mud still comes in from the well. I use a water filter to help, but it doesn't eliminate the problem. What do you recommend? So this could be a bacteria problem and maybe more.
Exactly, and the Lake of the Ozarks, that region has a very active and varied geology and a lot of geomorphology. So we have areas of slump, we have areas that get flooded, so a variety of challenges there, both at the surface and subsurface. If I were to see a surge in turbidity, of cloudiness, that would occur very shortly thereafter or during a heavy rainstorm, then I would be concerned that we've got a direct connection. And I'd want the well inspected to make sure that our well seal is present. So instead of drawing surface water, we're drawing groundwater. Depending on the breaches you're seeing at the filter system, you know, if the filter is just iron and we're seeing a breach of more iron coming through, I'd have less concern. But if we're seeing a heavy amount of sediment or rotten egg odors or musty odors, I'd want to take a closer look at that well system. You could have it sampled and evaluated for general biological population as well as the presence or absence of coliform, and may even want to see about, as part of that inspection of the well, having the well videoed. A camera survey or a video survey can tell us a lot about the structural integrity of the well that we don't see, that below the surface. And in the Ozarks, I've seen several wells that, because of shifting ground surface, they've actually become sheared or started to separate at joints, and so thus opening the well up to exposure of surface and shallow surface influence. So I'd certainly want to step up my investigative efforts there, especially if we're seeing a connection with rain events or surface precipitation.
All right, thank you. Here's another question. If my well is too shallow, should an entirely new well be drilled, or should the existing well be drilled deeper? So they're asking about this connection between the depth of the well and potential to be, I guess, contaminated by bacteria.
That's an excellent question, and in all honesty, it's really going to depend on the geology and soil layers present in your locale. There are some parts of the country that have shallow bedrock, some very competent geology that would limit influence on the shallow aquifers. There are other areas where there are substantial clay layers that further reduce the infiltration. If it is an older hand-dug or very shallow well, let's say less than 25 feet, I would be very concerned. And if you do look at well replacement, I would look at drilling an entirely new well. And my reason there is, as the older wells were constructed, especially the larger hand-dug type, they're set up to catch a lot of surface water and shallow subsurface water drainage. And you do not want that to continue with a newer well. So even though the upper section can be sealed and with cement or grout, you don't want to, you want to eliminate all those potentials of influence. So I would move over a good 10, 15 feet or further up gradient and place the new well as really a separate bore. Along that lines, in 2014, there was a two-part series in the Water Well Journal entitled, When is it time to replace my well?, which could be very beneficial to that participant today.
Okay, thank you. We have a question which I think is related to a septic system. It says our drainage field is only 100 feet. Well, wait a minute. The question just moved on me. Our drainage field is only 100 feet from the well, which is California code, and not as, I guess they're wondering if that is, well, they say, do you think that's safe? So it's according to code, it's only 100 feet from the well. Do you think that's safe?
That's a great question. And again, it's going to be specific really to the land. Most states carry a 100-foot minimum setback. My personal preference is a 100-foot minimum up gradient. So we would want the well up gradient from basically up elevation from the lateral field. As a potential influence, we'd have to take a look at the soil layers and where the aquifer units and rock units are in relation to. Generally, if we have shallow water less than 10 foot deep, so if it's at 5 or 4 or more, or closer I should say, then we're concerned of the septic influencing the groundwater supply. If we have shallow rock units showing up at less than 4 feet, we have concern that through fractures and over excavation that we're going to establish a conduit to the groundwater source. To reduce concerns, they could look at having a local engineer or possibly even their county sanitarian come out and conduct a soil profile analysis that would help identify the vulnerabilities of impact at that specific location, and that may just prove best. And then, you know, if you have a relatively close proximity lateral field and well system, at least once a year I would add those additional tests of total coliform presence and E. coli, just to rule out and to be in a more proactive standpoint.
Okay, thank you. We're getting several questions from people wanting to know different aspects of how much disinfectant to use and that sort of thing. So you might want to revisit that whole issue of well owners disinfecting their own wells. Nevertheless, I'll read this one. It says, sorry I logged in a little late, but I want to know how to determine how much chlorine, for instance, can be used for different sizes of wells. So I guess asking how does the size of the well affect how much disinfectant is used?
Well, generally, for larger well systems, our goal is to calculate a volume that is sufficient to flood the entire well system. So the standing water column, as well as an area to include the filter pack, and then sufficient volume to reach out into that near well aquifer zone. Typically, you can calculate the standing water column within the well itself and multiply at a minimum a factor of 2, upwards depending on the size of the well to a factor of 4. And then I would use that volume as the basis for mixing or calculating and then mixing a solution at the surface and displacing the volume of water within the well with that new treated volume. As far as the amount of chlorine, we recommend a range of 50 to 500 parts per million. We recommend sodium hypochlorite to avoid adding any additional hardness to the well system. And then, you know, generally the older a well is, you know, the chance for it being dirty or the chance for there to be a lot of iron that could neutralize, we would move from that 50 parts per million up to possibly 300 parts per million, but still falling within that 50 to 500 range.
Okay. We have a question. We had a well company do it, I assume disinfect. So we had a well company disinfect the well and it still failed. So they're wondering what could be, not having all the details, what could be the reasons for that?
Well, one of the most common we see, both in small backyard wells and in large municipalities, is that people use disinfection as the catch-all or the silver bullet. And disinfection will not, it's not going to sterilize the well. It's not going to break apart heavy mineral incrustations such as calcium carbonate or iron oxide. And it's going to do very little to break apart formation sediment such as sand or silt that is infiltrated over time. So I would say to the homeowner, if they did have a failure, then it's time to be a little more invasive in evaluating that well. collect a water sample, look at the potential problems there, and then sit down with the contractor. Okay, what can we rule out? Was there a problem with the methodology, or was the chlorine solution wrong? Did we rule out a breach? Did we make sure and account for pH adjustments of the background water? Is cleaning not enough? And just attempt to understand the well and the problems surrounding that led us to disinfection a little better.
Okay, thank you. Here's an interesting question. What products can be used to clean the well? So I think they seem to be drawing a distinction between disinfection and the cleaning process. How would you respond to that?
Well, there are a variety of products and methods for well cleaning. Typically, we recommend that you don't attempt to standalone pour chemicals in the top of the well, and that you understand what the problem is. Some wells respond to mechanical brushing very well, while others may require a light mineral acid or use of a biodispersant or a clay and silt dispersant. So we recommend you identify the problem and then incorporate a physical and chemical means of cleaning the well. Similar to what we talked about with regards to chlorine compounds, we strongly recommend the use of Nsf Approved Products for water well usage. There's a variety of Nsf Approved products for water treatment at the surface, for pipeline usage, for filter usage, and so forth. But look for products that are specifically designed for potable water well use. There are several manufacturers on the market, Design Water Technologies, AmeriWest, Johnson Screens, Lane Christensen. So take the time to understand the problem and then work with your local professional there to get the right materials and the right methods to treat that problem.
Great. We got some good questions here. Here's another one. Will a UV light kill bacteria without disinfecting the well first?
Well, UV and hydrogen peroxide have been explored, and chlorine dioxide as well, as alternate disinfection methods. The problem we've found with these methods, and even with light chlorination, if conducted on a new water supply with a very minor background bacterial population, they can be effective. But when you're targeting a larger bacterial population, and specifically some of the nuisance bacteria or more mature organisms or anaerobic organisms, these methods typically fail. And it's just a matter of having enough gun for the certain beast we're going after, for lack of a better way of putting it. With anaerobic growth, you've got to penetrate a much denser form of biomass. With sulfate-reducing bacteria, they're typically at the lower extension of the well, and that rotten egg odor that we see is really just a byproduct of their presence. So a UV system inline at the home is going to do little to combat that problem. A lot of the offending organisms that fall under the classification of coliforms are environmental coliforms, and in actuality facultative anaerobes that move freely throughout the lower portions of the well, both in the active and inactive zones. And they only trigger a test when one of them gets caught up in the grab sample. And so delivering that disinfection solution's got to get in the right spot, and it's got to be powerful enough without over-oxidizing the biomass, but to kill the bacteria. And some of those methods, the peroxide, the UV, and the chlorine dioxide, typically are not strong enough. Again, it falls back to really understanding the nature of the problem and the way the well's been maintained up to that point.
Okay, thank you. One person says, there is more to disinfection than I realized. Where do you think most well owners go wrong in trying to disinfect their wells?
Boy, that's a great question, and I'll put it blunt. The same problem with the backyard well owner hits the rural water district and even the larger municipality. They fail to understand the problems that are really causing what they perceive as a problem at the surface, and they attempt to just pour something downhole. The well is really a dynamic system, and we need to understand what challenges are present that are causing our concern for chlorination or disinfection. Is it an offending organism? Is it an odor? Is it discoloration or a loss of capacity or efficiency? A lot of those cases could be a structural failure or fouling that has occurred over time through the way we're operating it or just an extended amount of time and the concentration effect occurring downhole. And so we try and go after an elephant with a BB gun. And we try and do that from the surface of our large straw at the ground level, and really not getting the right materials down at the basement of the well or wherever that trouble zone is to alleviate the problem.
Okay, thank you. Let's see. I've heard the term disinfection byproduct. What does that mean? Is that something I need to be concerned about?
The disinfection byproduct comes from the overoxidation of biological material. And the concern in larger surface water treatment plants that draw off a reservoir or a river system is that their organic load is significantly higher than a groundwater source. And by oxidizing it with hypochlorite or a chloramine solution, we have the disinfection byproduct created. And the disinfection byproduct can be carcinogenic. In well systems, the biological load is significantly less, just on a general comparison basis to surface water. Now, if we had a heavily fouled well, that is a well that is dirty from biological buildup over time, we do run the risk through overchlorination or shock chlorination of creating disinfection byproducts. So that's why it's wise to test the well, understand the population and the microbial load that exists, and see if additional cleaning is necessary prior to our disinfection efforts. That is a great question.
We still have a little time left, so if people have questions they want to ask, type them in that question box and we'll try to squeeze them in. I have a question here. Are you saying if I remove my well cap, even for a little while, that could allow bacteria into my well?
That's a good question too. And I'm just going to say that a well is a lot like an idle teenager. We really don't want to leave them up to their own devices. So if we remove that cap and we're right there over time holding the cap up in the air and watching what's going on, we'll be okay. That doesn't always occur. And that's why I've got a collection of well videos and pictures of birds, snakes, mice, and potato chip wrappers, oh, and I forgot a Gatorade bottle, that have occurred downhole when someone turned their head. So just by opening it, you're not going to jeopardize it. But if you're introducing or removing anything, or if you set that cap down and look away, then you enter into the unknown. And that's when it's best, as a proactive means of maintenance, to disinfect the well.
Okay, thanks. Here's another question. We have one earlier relating to septic systems. This is more general. Can septic systems cause bacteria in my well? Should I be concerned about my septic system? So I think they're looking for some general guidance about that.
Well, you know, there is a lot of concern, and I guess what I would first look at is, are we dealing with a modern home setting? And by that I would say something within the last 20 years. Typically in that time period, most states and most counties, as part of that reaction, have issued more stringent guidelines for the choice of a home septic system and well. I would also look, as part of the permit, was the site characterized what's commonly referred to as a soil profile? So was it site-specific, an evaluation conducted of groundwater presence, geology, and then the soil conditions there, instead of just looking at a book and saying, well, the state guidelines for this area is a subclass of XYZ. You can, to rule out, periodically test your well. Look for the presence of fecal coliforms. You can look at nitrate levels and look at conductivity, all of which will give you a good indication: is the water typical of background, or is it showing a potential septic influence? The fecal coliforms are kind of a no-brainer there, but the others show an impact in the general water chemistry that could be tied to a septic system. I'd say one of the more common influences we see is from water softening devices and the brine solution or the heavy congested water chemistry solutions that are disposed of, sometimes in septic systems, sometimes through a gray water line. They tend to have more of an impact on well systems than failing septic systems.
Okay, thanks. Here's another well cap related question. I needed a new well cap and there were many different kinds. Any tips on what to look for? So I guess they're concerned about bacteria getting in there, and is there a difference between them that they should be attentive to?
My favorite are, for lack of description, the ones that look like the vacuum wine bottle sealing, where you have the little lever and it seals out the portion that is stuck into the well. A lot of those are also lockable, which just helps to rule out any potential vandalism or unruly influence there. You know, the common PVC cap that is just attached on is certainly easier for access, but at the same time it's easier for access. And so just a curious individual can always open it up, take a peek, and even possibly walk off with it. In addition to getting a good cap, I also recommend that people take the time to evaluate the landscape around the wellhead, make sure that it shunts water away to prevent pooling. And if you do have a well house or a shelter for the well, make sure that it's kept clean and not home to snakes, rodents, and insects as commonly occurs.
Well, it looks like we're out of questions, and it's just about 2 o'clock. So if there's anything you want to add, Mike, go ahead, and then we will call it a day.
Well, I thank everyone for their patience and for tuning in today. I do strongly recommend you look at wellowner.org for additional information, as well as a variety of articles that are available in the Water Well Journal pertaining to well maintenance and well ownership. And unfortunately, I'll leave you with this. Wells, all too common, are an out-of-sight, out-of-mind resource. And unfortunately, backyard wells and large municipality wells suffer from the out-of-sight, out-of-mind, run-to-failure attitude. So any efforts you can do today in the proactive, preventative maintenance category will pay off dividends in the future for a longer lifespan of your well. Thanks again, and good luck.